Hello and Assalamualaikum. This video is about daily Koumiss has positive regulatory effects on blood lipid and immune system. For the introduction, Koumiss is a traditional fermented dairy with rich and made from horse meat originating from Central Asia and documented early as the Yuan dynasty. It is naturally fermented by lactic acid bacteria and yeast and is known for its less sweet, sour, and mildly astringent taste. Traditionally, it is believed to benefit health by nourishing the stomach, moistening the lungs, improving sleep, and promoting blood circulation. Koumiss is nutritionally rich, containing amino acid, unsaturated fats, lactose, vitamins, and minerals. Modern research highlights its potential therapeutic effects and such enhancing immune function and offering support against cardiovascular, digestive, and kidney disease. Such this, the study applied metabolomics technique that profile change in body metabolites to understand the broader metabolic influence of Koumiss and may therefore its feature used in daily diets and functional dairy therapy. In this study, Koumiss was tested for its effect on metabolism using rats and advanced analytical tools. 20 male rats were divided into two groups, one received Koumiss and the other received saline for 8 weeks. Blood was collected and serum was prepared for analysis. Samples were treated with acetonetrol, filtered and analyzed using UPLC. The analysis involved detecting and comparing metabolites in both groups using specialized software to identify significant metabolic differences. Identified compounds were matched against major database and statistical analysis was done to confirm any significant effects of the Koumiss. The objective of the study was to investigate the systemic metabolic effects of daily Koumiss consumption on daily healthy organisms using metabolic analysis. The conclusion of the study is Koumiss is nutritionally rich traditional fermented product that exhibits therapeutic potential in modulating lipid metabolism, boosting immune function, and supporting cardiovascular and nervous systems. The result we get is Koumiss can enhance immune function, regulated blood lipids profile, significantly reduce blood triglyceride levels, and alter key metabolic pathways, and P3 identified is 43 potential metabolic biomarkers with several showing increased nutritional compounds.
Assalamualaikum, my name is Nur Natasha and I will be presenting the principles of the metabolomics approach used in this study as well as its real-world applications. First of all, what is metabolomics? Metabolomics is the large-scale study of small molecules known as metabolites within biological samples such as blood, urine, or tissue. These metabolites reflect real-time physiology changes, and metabolomics is often used to monitor responses to diet, disease, or treatment intervention. In this study also, the authors employed UPLCQ or TOFMS, which stands for Ultra Performance Liquid Chromatography, coupled with quadruple time of flight mass spectrometry. This powerful analytical technique allows for separation detection and identification of a wide range of metabolites based on their chemical properties. After data collections, the results were analyzed using multivariate statistical tools like principal component analysis (PCA) and partial least squares discriminant analysis (PLSA). These tools help the researchers detect a significant difference between the metabolic profiles of the control and Koumiss-treated groups. To understand the biological impact of these changes, they used databases like KEGG, HMDB, and the MetaboAnalyst platform to conduct the pathway analysis. Through this, they also identified that Koumiss had a regulatory effect on several important pathways, including lipid metabolism, amino acid synthesis, bile acid biosynthesis, and vitamin metabolism. As for the application, this study demonstrates how metabolomics can be used to scientifically validate traditional functional foods like Koumiss. Koumiss consumption show beneficial effects on cardiovascular health, such as reduced triglyceride levels and supported immune function, also as evidenced by increased the levels of immunoglobulins and cytokines. Therefore, the research has potential applications in nutrition, preventive medicine, immune therapy, and the development of functional food products. Okay, now I will discuss the advantages and limitations of the research. One of the key strengths of the study is its use of multiple bioinformatics tools and databases to support metabolite identification and pathway mapping. The authors also reference previous studies on Koumiss showing consistency with past findings related to immunity, probiotics, and metabolic regulation. Additionally, the study used advanced analytical instruments, namely UPLCQ and TOFMS, combined with robust statistical methods. As a result, the researchers were able to confidently identify 42 key metabolites that were significantly altered after Koumiss treatment. However, there are several limitations to consider. First, the study was conducted only on rat models. While rats are a useful starting point, the effects observed may not fully represent outcomes in humans. Secondly, Koumiss is a naturally fermented dairy product, and its composition can vary depending on the region, the microbiome content, and fermentation conditions. This lack of this lack of standardization could make it difficult to reproduce the same results in larger or commercial settings. Furthermore, the study duration was only took 8 weeks, which may not be sufficient to capture long-term effects or side effects. So in the conclusion, the study successfully used metabolomic approach to reveal that Koumiss is positively regulate metabolic and immune pathway. However, to support it is used as a functional food or health supplement, long-term and human-based studies are very essential. Thank you. That concludes my section on the principles, application and evaluation of the study. I will now pass it on the next presenter.
Hi, my name is Sita Eshamitujuso. I would like to share the bioinformatic and metabolomic tools that have been used in the study of health effect of Koumiss, which is a traditional fermented strain, where the scientists collected the blood sample from the rats that drink the Koumiss milks every day and that were not drink the Koumiss milks. They scanned the sample with the advanced equipment such as the UPLQC-12MS and identified thousands of chemical signals. All the different compounds such as amino acids, lipids, vitamins, and other small molecules correspond to different signals. However, that poses an enormous problem. Data is huge, untidy, and confounding. Then there is where the bioinformatic tools come in. Metabolomics was employed to control the influence of Koumiss on the metabolism of rats by the scientists. This produced thousands of chemical signals to which they supplied bioinformatic tools to read them. To sort the information and prepare it, marker view was used, and which is benefits in align pits from different samples, remove background noise, normalize the data, fill in missing values. Next is sync-up is identified pattern that made the difference between Koumiss and control group. As sync-up performed techniques like the principal component analysis, PCA, or which group similar samples together, and the partial least square discrimination analysis, or PLSDA, which highlights the differences between groups. In this study, sync-up revealed clear differences in metabolites patterns between rats and that drink the Koumiss and that doesn't drink the Koumiss. This suggests Koumiss significantly altered the metabolism. Then, they use a pit view alongside database like HMDB, PubChem, NIST, MassBand to help them identify the detected compound, which is the molecular interactions was also learned through these bioinformatic tools like PubChem that offer observing the 3D structure of a molecule in this study such as valine. One compound they detected was valine, essential amino acid. They look up valine in HMDB and PubChem to confirm and identify and learn about the biological functions. And in PubChem, they also could even view the 3D molecular structure to see how it might interact with the other molecules in the body. Then, the KEGG and Metabo analysts subsequently play this compound in metabolic pathway, which show how Koumiss could affect its lipid metabolism and immunity. Lastly, statistical significance had been agreed upon by using SPSS as a way of ensuring reliability. They performed a t-test to check whether the differences in metabolites levels were significant or just random chance. Taken together, these tools translated complex data into all important information on the health effect of Koumiss.
Firstly, we search for HTTPS HMDB.ca and we type valine as in this study. The researcher won't discover the chemical structure, molecular weights, and metabolites are found throughout the bodies for valines. And you can see the details of valine here, such as the structure, the synonym, and the chemical formula, the molecular weights. And also, we can see the iPad name, the traditional name. And then we scroll again. We can see that alternative parents, substituents, and besides, we can see the spectra. Here is the spectra as predicted in the HMDBs for the valines. You can see the ionization mode. And then next we go to the PubMed, research valine again, and then we can see the structures for valines. This is the 3D structure of chemicals and the interactive or this is a little of the values for the compounds. You can also zoom in or zoom out for these chemicals compound. And beside, you can move the structures by choosing the chemical structure you want to see. The models such as the ball and stick or wireframe. This is a wireframe, and also the space filling. Right. And then we go to TEGG, as this is database used for mapping the metabolites into biological pathway for the valine, and you can search its here. Then we can relate this chemical pathway that affects on health. Alright. Okay, that's all. Yeah.
To conclude the study, Koumiss is a traditional fermented product with strong nutritional and therapeutic potential. This study demonstrates that daily consumption of Koumiss, a traditional fermented dairy product, exerts beneficial effects on blood lipids regulation and immune function in healthy rats. Using advanced metabolomic techniques, we identify 42 significant metabolic markers and observe changes in key metabolic pathways, including lipid metabolism, amino acid metabolism, and vitamin biosynthesis. These findings suggest that Koumiss has potential to function as a therapeutic nutritional supplement or functional food. However, further research, including human clinical trial, is necessary to validate these effects and support its broader tertiary application. That's all for our group. Thank you for watching.